Hey, what's up, guys? Mr. Cruz here to give you guys notes on scatter plots. Now, with um, scatter plots, I feel like it's a pretty easy topic to kind of understand. The only kind of complication comes from uh, realizing like the independent and the dependent variable, and then kind of seeing the trends. But we're gonna go over it. But again, like scatter plots, a lot of it is just like looking at it and finding what's called the line of best fit, which is actually pretty simple. So let's go ahead and get into scatter plots here. So the reason we use scatter plots is because scatter plots, they're a type of graph, and then just like every single kind of graph, we use certain graphs because they fit, or they give us a better purpose in terms of things. Like, for example, line graphs are really good for telling data over a set of time. Um, Something like we had recently gone over box plots. Box plots is good because it breaks up all of the information, all the data, into 25% quarters, into like sections of 25%. Scatter plots, the reason scatter plots are good, or the reason why people would use them, is because scatter plots allows us to compare two different things that might not seemingly have an effect or have any kind of relationship with one another. And then when we input our data and create scatter plots, we can kind of see if the height, if like somebody's height affects like the size of their shoes, or if how old somebody is determines how many invitations they get for birthdays. Like two things that might have a relationship, like one might have an effect on the other or one might not have an effect on the other. Those two things we can kind of see in a scatter plot if they actually have some sort of trend. But in scatter plots, we call those relationships. So what are scatter plots and why do we use them? So they illustrate a relationship between two variables. There's usually a dependent variable and an independent variable. The independent variable is something that will never change. So I say not something that will never change, but it's something that is not affected by something else. So, for example, when I said like, hey, do we get um, do do we tend to send out more birthday invitations the older we get or not? So your age would be an independent variable, because even though your age changes, your age is not dependent on something like how many invitations you send out. As you get older, you might have more friends or you might have less friends. So the amount of invitations you send out would be considered the independent, or no, the amount of invitations you send out would become the dependent variable. So it says here, our next point is, in scatter plots, each point may represent an independent and a dependent variable. And then the independent variable is something that is not controlled by something else. Um, Scatter plots can be used to predict trends. Sometimes they're called the line of best fit. And that's actually something that you guys are going to be doing on your assignments, is you're going to be determining what is called the line of best fit. And again, some of this stuff might not make sense right now, but when we get into some examples, it'll kind of come to light here. And a scatter plot can show us different types of relationships between variables. So a relationship can either be positive, it could be negative, or there could be no relationship whatsoever. And I'll show you what those look like when we get to seeing some examples of scatter plots. All right, so here, our first example, it says part-time employees at a small business get paid hourly wages based on how many years they have worked at the business. Plot the data in a scatter point. Plot the data in a scatter plot. All right, so up here at the top, we see this is our data. All right, ooh, can I get this here? Oh, let's go. All right, so the amount of years that somebody works determines their hourly wage. So their hourly wage is dependent on the years, right? Years are not going to change. So our years would be our independent variable. So let's go ahead and plot this here. So if you worked 0 years, or if you have no years of experience, you get paid $5.50 an hour. If you have a year's experience, you get $6.50, so on and so forth here. So if we plot all this data right here, what we're going to look for is the line of best fit. And the line of best fit in this case looks like this, right? It's really, you're really just kind of picking 2 points on a scatter plot and then drawing a line connecting those two. Typically, you would want to find a line that's kind of closer to the beginning and then closer to the end, to be able to have that line seemingly go through or as close as possible to the rest of the other points that you have plotted. Now in this one, it's a lot simpler, but when you get to kind of like bigger, more complicated ones that have a lot of information, those can be a little bit more complicated or a little harder to determine what the line of best fit is. But usually you're just following the plots of line or the plots of points that you have plotted on your graph, and then seeing if you can draw a line that is consistently in line or close to all of those points. So this one, since our line is going upward, this would be a positive relationship, right? Because it is increasing. The more years you work, the independent variable means the more money you work, or the more money that you can earn, i.e. the dependent variable. All right. So these are kind of what our relationships would typically look like, right? So this one here is talking about the degrees above 13 degrees Celsius. Man, Europeans. So this one, our line of best fit looks like it would be right here. So this would be a positive relationship. This one right here, shoe size and score. I believe this plot right here, I was saying, does the shoe size of a basketball player have any kind of impact on the amount of points they can score? And it turns out in this graph, we see that there's no relationship. Reason being because you can have big feet and be trash. You can have small feet and still be trash. So the size of a basketball player's shoes does not determine or dictate how good they are as a player or how many points they score. So in this case, these two variables, the shoe size being the independent variable, has no relationship. So one of them does not affect the other. This one, I don't even have like the information, but clearly our line of best fit is this way right here. And this is showing me a graph that has a negative relationship because it is going downhill. All right. Line of best fit, positive, no relationship, and then a negative relationship. All right. And that is really it. That's the bulk of what we're doing when it comes to scatter plots. Now, stay tuned for the next video because I'm going to go over the IXL to show you guys how you kind of select, because those answers are asking the exact same stuff that we went over. Like, hey, is it a positive? Is it a negative relationship? But the way they word it is kind of difficult. So in the next video, I'm going to show you guys how to get to the IXLs and be successful at it. All right. See you guys next time. Bye.